This is a neuron that will undergo an action potential. First, I will point to the structures of the neuron and explain them. The yellow branch-like structures are the neuron's dendrites. The pink circle structure is the cell body, and the green circular structure inside of the cell body is the nucleus. The orange dots on the blue axon, these are the myelin sheath. And in between these, so this branch of the blue axon, these are nodes of Ranvier. And this entire structure that my finger is going down is the axon. The pink structures with bulbs on the end are the axon terminals, and the bulbs on the end are actually neurotransmitters. The green circles you see here are potassium ions in the intracellular fluid with a positive charge. And the yellow circular structures you see are the sodium ions with a negative charge in the extracellular fluid. So the first step that will occur when an action potential is generated will be the axon terminals binding to another neuron's dendrites whenever a stimulus becomes stimulated. This could be pain, arousal, etc. And the action potential will travel down the dendrites into the cell body, and it actually starts an action potential in the axon. So this right here would be the axon hillock. So after the action potential is generated in the axon, as you see by my finger, the first step that will happen is the sodium channel gated ion channels will open, and the sodium is forced into the cell, into the intracellular fluid where the potassium ions are. So essentially, the sodium ions and the potassium ions will start to switch places. So now that the sodium ions and the potassium ions have switched places, you can also see that now the neuron's charge is now a negative in the extracellular fluid and a positive in the intracellular fluid. After the sodium ion channels have opened and they are forced into the cellular fluid, the neuron starts to depolarize. And so after the depolarization, the potassium ion channels open and the potassium ions are forced out. And that is what happens when the sodium ions are forced in and the potassium ions are forced out. So essentially they switch places. And whenever this occurs, the neuron is still depolarizing. Whenever the action potential is at its utmost peak, the sodium channels start to close and the neuron starts to repolarize. After this happens, the potassium channels close and they start to come back in. So they start to switch places again after the action potential has been generated. So after the potassium ions have flooded out of the cell and back into the cell, that is called hyperpolarization. And once the potassium channels close and they are back into the cellular fluid, the resting potential is reestablished, which means the action potential has been generated.